You obviously want to go beyond the basics. Well, you've come to the right place. We'll help you progress as a pilot, taking the next step to advance, to excel, to master ground handling. Please understand that this video is not intended for self-training, a dangerous path whose risk is not always obvious. Having competent, certified instruction dramatically reduces your risk, a risk that includes serious injury or even death. Some of the techniques shown here require high-level skills, wide-open areas, proper equipment, and even with instruction, are very dangerous. The minute you hook into a wing, there's risk. More wind, more risk. Pilots have been seriously hurt doing these things, especially in high winds, and even more so on their own without high-level instruction. Always, always seek out qualified training. Ground handling is making the paraglider do what you want, when you want, with your feet or wheels still on the ground. This video, along with expert instruction, can help you become a master wing handler. You will learn to finesse the wing, a finesse that will improve safety, ease your launching, and add more fun to your flying bag of skills. Your skill here largely determines your launch success and what conditions you can safely operate in. It will help you become a master of the air as well as the wing. And as many pilots have already found out, the best ground handlers are the best launchers. A lot of the skills required of soaring pilots are the same as for powered flying, but there are differences. For example, handling strong winds on an upsloping mountain is different than handling them on level ground. We will concentrate on the skills for motor pilots and add a few extras just for sport. If your goal is free flight, seek out expert free flight instruction. There you'll learn many important and unique techniques that require specific skills. But if you plan primarily on motoring, choose an instructor who understands the differences and can help you master the techniques covered here. Either way, don't skimp on expert instruction. Its guidance will dramatically smooth your way. We expect that you already know the basics: parts of a paraglider, building a wall, and kiting in steady winds. Techniques covered here will build on those basic skills and broaden the conditions you can operate in. Just as importantly, these skills will add new ways to have fun with a paraglider, and there are many. One caveat: like any motor skill, it requires practice, lots of it. And it's a perishable skill. If you go a long time without practice, expect it to wither. But if you practice intensely for at least a couple of weeks and achieve a high level, the skill will survive even after long periods of inactivity. First, let's review some terminology along with a quick refresher. Inflation is getting the wing to first take shape, then come up overhead. This is a reverse inflation, where the pilot is facing the wing. A forward inflation is where the pilot runs with the wing coming up behind him. The wing's power band is where it pulls the hardest during inflation. It's generally just after coming off the ground to being about halfway up. If you're gonna get yanked, it'll happen here. The airflow experienced by the wing is relative wind. When you're kiting in a 5 mph wind and walk backwards at 2 mph, the wing is feeling a relative wind of 7 mph. Run backwards at 4, and the wing sees a relative wind of 9 mph. Wing chord is the distance from leading edge to trailing edge. It's usually referred to as an average since the chord is large at the center and decreases at the tips. Here the center chord is 2 meters, but the average chord is 1.6 meters. Span is distance from wingtip to wingtip. Wing area is size, usually measured in square meters. Flat area is the area of the wing laid out flat on the ground. Projected area is the area of an inflated wing's projected shadow. Projected is the more important number because it's how much area the wing has in flight. Wing loading is how heavily loaded the wing is, usually measured in pounds or kilograms per square meter of projected area. 200 pounds of pilot, wing, and motor on a 20 square meter wing has a wing loading of 10 pounds per square meter. Aspect ratio is the ratio of wing span to average chord. Higher performance wings tend to be long and skinny, a high aspect ratio, while lower performance models are stubbier. Among other things, aspect ratio affects kiting behavior, with the long, skinny wings being harder to handle than the shorter, fatter wings. Mostly this is because the tips of such gliders collapse earlier at a given brake pull than their beginner wing counterparts. The 4 risers on most wings are A, B, C, and D. Trimmers make the wing faster by extending the rear risers and changing the load distribution, effectively decreasing the wing area. Most wings also have a speed system. Pressing on the speed bar pulls down the A and B risers to speed up the wing. It reduces the angle of incidence, which speeds up both the descent rate and forward speed. Generally in kiting we don't use the speed bar, but we do have the trimmers set to their slow position. The angle made by the relative wind and chord line is angle of attack. It must always be positive since lines can only pull, they can't push. For example, while kiting, as the wing starts out, its angle of attack is huge. As the wing comes overhead, the angle of attack gets less and less. When it's overhead and in the flying position, the angle of attack is about 20 degrees. There are 3 axes of motion that we'll refer to. Roll is left-right banking around the roll axis. Yaw is the wing twisting left-right around the vertical axis. And pitch is fore-aft movement of the wing around the lateral axis. Nearly all kiting will do is reversed with the risers crossed. Brake holds will vary, but if you're holding the toggles, always have the correct one in each hand so that turning around would leave you ready to fly. Let's take a look at gear for kiting. There are several choices for kiting harnesses. After basic structural integrity, your most important criteria should be comfort. You won't practice long if it hurts. Some instructors rightfully want you to learn initially on something that approximates your motor's hook-in, but for mastering the wing and the extensive kiting it requires, you'll need a comfortable harness. Anatomy dictates that the wing hook in near or slightly above your hips. That puts the center of lift just above your center of mass, and importantly, where it does not require back muscles. Here are the basic kiting harness styles. Paragliding harnesses are used by free flight pilots. They work well for kiting and obviously work great for soaring. Plus, they employ various types of protection, especially for your back in case of crash, but they're bulky. That makes them awkward for extended kiting sessions. Lightweight versions are better, but they still might be bulky. Paragliding alpine harnesses were designed for those who hike up mountains and fly down, a use that dictates their lightweight design. They're expensive but comfortable, and they're great for kiting, especially in strong winds. They do not, however, have any significant protection. Purpose-built training harnesses work well as long as they're comfortable and allow hook-in points near your waist. Many allow either high or low hook-in points, a great compromise. Harnesses made for mountain climbing work even though they are not made for our application at all. Make sure to hook in your carabiners around the harness main straps, not the tool hoops. Only use the tool hoops to keep the carabiners separated if you use them at all. Utility, military, and homemade harnesses can work too, but make sure they're flight-worthy and balanced. You will likely get lifted at some point and your harness must be up to the task. And always use flight-worthy carabiners for the same reason, regardless of what harness you use. Lastly, paramotor harnesses can work, especially those that detach easily and hook in low. These can actually be quite good. They're usually comfortable and you always have it with you. Motor harnesses that come from high hook-in machines will be less comfortable if you try kiting from their flight attachment points. Whatever you choose, try it out first if possible. And the only real way to try it is by kiting. Hanging in a simulator is different, although it will give you some idea. If the harness isn't comfortable, then try adjustments. If that doesn't work, try another harness. Some wings are a lot easier to kite than others. In general, you should master the wing you fly, but it can be helpful to choose an easy kiting wing in some situations. For example, if you plan on launching from confined, really confined areas, where you won't be able to move left and right, or you plan on reverse launching with a cart, it's much easier to use a lower aspect ratio wing. The difference in kiting, where you cannot move your body, is dramatic. A high aspect ratio wing is harder to recover when it gets crooked. The low aspect ratio will stay fully inflated longer, so you can use a lot more brake pull and right it from being farther off. Stronger winds make this less of a problem, but the difference always exists. You'll always be more successful with a short, stubby wing rather than a long, skinny one, especially in situations where your body cannot move much. Strong winds are dangerous. Knees get scraped, line burns are a real possibility, and heads can whack where they shouldn't. Consider wearing protective gear, helmet, gloves, and knee pads to make the inevitable dings and scrapes much less painful. Your choice of location and conditions will determine safety and how quickly you learn. The stronger the wind, the more critical your choice, and always be aware that the wind can suddenly increase. Seek out an open area that's not in rotor and has nothing downwind that you wouldn't mind being dragged through. The more open, the better, not just for safety, but also to avoid being in turbulent air, which makes learning so much more difficult. If you're learning high wind techniques, talk with locals about where to find a likely strong, steady wind condition. Traveling may be your best bet. There are places on the planet that excel in delivering predictable, steady winds. For example, Salt Lake's Point of the Mountain and many beaches are great sites. If you can get to one of these spots, or find yourself there for other reasons, take advantage of it. A couple cautions though. Never subject yourself to a place that could blow you into water, power lines, people, or other hazards. Even experienced pilots can lose control and weather can change. A wing in a wind has enormous power. Before clipping into a wing, you should know how to depower it. Just like kiting, there are many ways to do so, but we'll concentrate on those few that have proven most effective. Some fancy methods for killing a wing have been developed, and in skilled flyers they're fine, but they may not be as reliable for many pilots. Hopefully you're doing this practice with an instructor, but if you're just out practicing with friends or other pilots, make sure they know what to do if you start getting dragged, namely to stand downwind of the wing and go for fabric if things go awry. They must know not to grab you, rather grab the fabric. One good method is to have someone stay downwind, and if things do go bad, they can just let the wing drape around them. The standard way to bring a wing down is simply pulling the brakes. That works fine in a moderate wind up to about 12 miles per hour, but not so well in stronger winds. In fact, it can be difficult to get the wing down at all in real strong winds. At that point, you'll either need another method or can expect to be dragged. In the highest winds, you'll benefit from knowing some of these techniques. One method we call the overfly. When you're ready, get the wing to overfly you slightly, then pull full brakes. The wing will come crashing down through the power band with a brief, powerful yank. Notice how it's done nearly all at once. Release brake pressure and squat down to get the wing moving forward like it's going to overfly. Then, when it's at its most forward condition, almost past your head, pull hard on the brakes, all the way. Even in the strongest wind, you'll only get yanked a few feet. You can improve the technique by stepping forward just as the wing gets to its highest point. The idea of this technique is that you pull the wing into a full stall while it's directly overhead and before it has a chance to start yanking too hard. For maximum finesse, soften the wing's touchdown by letting off the brakes as it nears the ground, but don't bother with this in really strong conditions. Another method is to reach up and pull the C risers. Find them first visually so you can grab them quickly. Reach as high as you can so you can pull them a long ways down. The wing depowers immediately and will flail a bit on the ground. If you have a helper, get him to grab a wingtip and walk it towards you. If you're alone, try running towards the nearest tip and grabbing it yourself. You can do the same thing but use the B risers in place of the C's, and on some wings that does work better. Pulling the risers like this can be tough since they're hard to find when you're bouncing around. Rehearse doing it in mellow conditions before doing it out of necessity. Rehearse it while facing forward and while reversed. It can even be done if you end up getting lifted, as long as you do it before getting too high. This technique is good in that it works without your feet being weighted as other techniques require, and it's an important tool to master. If you have a helper present, here's one way they can bring the wing down without causing you to go tumbling. Have them grab both brake lines and walk briskly upwind while hanging on. You may get airborne briefly, but the wing will come quickly stalling down, and you don't get yanked downwind since the wing is held disabled by the helper. This method works great for either forward or reverse situations. In fact, you can be airborne and this technique will quickly plop you back to the ground. Of course, the helper has to get to the brakes first. If none of this has worked and you're getting dragged, here are some tips. Pull on one brake and keep pulling it hand over hand until you're holding fabric. If you aren't holding a brake, grab any one line and pull, but only do so if you have gloves, and even then there's a good chance for line burns, so only do this if you're getting dragged somewhere you really don't want to go. If you can get to your feet, run towards the wing, trying to grab fabric and reel it in towards you. Prevention is obviously best, so build up your skills gradually, sticking with conditions you can handle and locations that are forgiving. Once you have the wing down, hold both brakes back, but not so far that air gets underneath the trailing edge, causing it to snake up. If air does get under the wing, let off the brakes until a wall forms. Remember that you can disable the wing by pulling one brake hand over hand until you're holding tip fabric. Continue pulling fabric towards the center cell by grabbing just above the cell openings. Once you've got the center cell or thereabouts, it's easier to manage. Also, you can do a crude fold while doing this to avoid tangles. Another option for stowing is to put a weight on the upwind wing tip and let the other tip trail downwind. Lay the risers down away from the other lines, then fold it from the upwind tip. It's easier to do with two people. With only one person, it winds up getting mostly rolled up. As long as the risers don't go through any lines, it should not be that hard to sort out later. Be quick to unclip. Anytime you're clipped in, there's a risk that part of the glider could catch air and start to inflate, taking you for a ride. It doesn't take much, but keep the risers away from fabric and other lines to avoid getting tangled. Another approach to deflating in high wind is the D-pull rosette. As we'll cover later, in really strong winds you might want to kite with the D's instead of the brakes, but you can still get pulled or lifted. This deflation technique is good for such situations. So if it gets too strong, or you've just had enough, do the following. Bring the wing down by pulling and holding the D's. Once the wing is suitably stopped, move the D's into one hand and hold. With your other hand, sweep around all the lines, grasping tightly so as to keep the D's pulled. Walk around it if necessary to prevent reinflation. Bundle the wing tightly, keep it upwind, and you're ready to stow. Here are some concepts that will make your kiting efforts more effective and fun. First, minimize brake input. Like all flying, your goal is to use the least amount of control input necessary to achieve your desired result. You may succeed with excessive brake pulls, but it will be tiring. It will also tend to make the wing want to fall back and will be far more difficult. By mastering control through minimal input, you will endure longer, gain a better feel, and make it look that much easier. Think finesse, not flail. This pilot is keeping the wing where he wants it, albeit with great effort. An onlooker would think, man, that looks hard. The pilot is getting a great workout to be sure, but would wear out quickly at this exertion level. Plus, by having so much input, he won't feel the wing as well and has more chance of getting lifted. In the same conditions, this pilot is keeping the wing where he wants it too. And he could do it all day. This is what you want. An onlooker would think, wow, that looks easy. Your goal is to make ground handling look like your grandmother could do it. Minimize brake inputs, minimize body movements, and see how little you can get away with while still maintaining control. Knowing how to move your body is important, but again, use the least amount of movement necessary. Strive to control the wing with brakes alone and only small body movements. It's true that sometimes moving is the best control input, but you may find yourself in a position with little room to move. You'll be glad you mastered kiting with just the brakes, using only what's necessary and nothing more. The body motions of a skilled kiter will be subtle. If a wing displacement can be corrected with brakes alone, do so. But of course, if the wing gets off so far that moving is the only option, then do what it takes and no more. There is also benefit from learning how to control the wing with only body motions. You'll learn what and how much movement to make. The idea is to learn subtlety, and to do so you must know what each movement does and how much it takes. We'll cover that shortly. Speed is life. Speed is control. Speed in this case means relative airflow over the wing. In almost every situation, when a wing is not obeying, get more airflow over it to improve control authority. That usually means backing up, or if you're already backing up faster. In lighter winds especially, moving will improve your success when things start to go awry. It may in fact be the only body motion necessary. Here are your primary tools of control. First, the hands. Number 1. Brake input to control left and right. This is nearly the first thing every pilot learns about kiting. Number 2. Brake input to slow down the wing, or letting up on the brakes to let the wing fly. Number 3. Using the D's just like the brakes. Pulling the D's on one side slows that side down, just like the brakes, albeit less effectively. You'll see later this to be a good method for strong winds. Number 4. Using the tip lines to control left and right. This is an especially good technique for kiting some reflex wings in strong winds. They sometimes have special handles that do more than tip lines. They cup the trailing edge too, making them more effective. Here are the body motions at your disposal. Number 1. The most common is left-right. The wing goes left, you go left. Only more if you can't or don't want to use the brakes. For example, if you're in an open area with light winds, it's better to use body movement than brakes because brakes will tend to kill the wing. But if you're in a confined area with little room, you'll be glad you mastered kiting with minimal motion. Number 2. Back and forth. Stepping backwards immediately gives the wing more relative wind, and that means better control. If the wing has come forward and you did not dampen it quickly enough with brakes, you can frequently prevent it from collapsing just by stepping back a bit. Number 3. Up and down. Squatting low makes the wing want to come forward, albeit briefly. Letting yourself rise up in a gust may prevent getting lifted off your feet and losing control. And number 4. Riser shift left and right. Leaning left pulls this riser down. The wing always wants to yaw or turn in the direction of the lowered riser, so leaning left will make the wing want to go to your right. The gross motions of left, right, and back and forth are the first to master. Then add in squatting and finally riser shift. How you lay out the wing depends on the wing style, surface, preference, and winds. First, ensure the lines are clear out to the wing, starting with the A's. No lines should be draped over them. You can also check the B's, but, as with other lines, primarily ensure they're not snagged on anything by pulling up just enough to raise them slightly. Then pull the brakes out enough to tug slightly at the trailing edge. That ensures they're not snagged. Two basic layouts are common, straight and V. We'll start with a V layout. The V-shaped layout may be better for some wings, especially those that tend to come up crooked. Inflation from a V layout pulls the centers first, giving slightly less chance for one side to rocket up, pulling the whole wing over. Plus, the U or V shape helps avoid pulling on the outboard leading edge.